13
13
students.
students.
Yes, and I think they will also join. They will also join. I'm sorry for that 10 to 15 minutes break because I didn't do the breakfast, and I have a bad habit of doing breakfast late. That's why it creates problem.
Same here,
And
sir.
uh, I'm just sharing my screen. Okay. Today the topic is interestingly our we are right now in such a situation that we have already enough knowledge. That means that now if we study more, we can understand from there on, because I believe that my students have already have that understanding of uh, what is electronics, what is at least the diode, how it works. Because next probably the next after one classes we will start the transistor, a new topic. We'll also deep take 5 6 7 classes of that. uh, so it will be very, at least I believe, I will believe that my students will never have less knowledge about diode and transistor, because these two are the basic of electronics. And when you go to the next semester, the electronics 2, you will learn much more different applicational devices. That is electronics 2. Okay, but electronics 1 are the basic of diode, transistor. These two are very basic and interesting thing, because this is the foundation is very important. Okay, my student, I will not talk more. Can you see my screen, my student?
We can
Can you
see
see?
it
Okay, can you see?
properly.
Yes, sir.
Okay, so basically our first lab was the study of diode IV characteristics curve. We have already discussed too much that IV characteristics curve, but still we'll go through. First of all, we'll go through today, just today, our first class. We discussed this. This is the the IV characteristics curves that were we basically discussed or just shown the forward biased condition and the reverse biased condition. So what we'll do in our laboratory class. Is done by us, and learned by us theoretically, but in practically what we'll do, we will connect the diode, same thing. We connect with the DC source, and then starts to give the positive voltage and the negative voltage, and we'll check that how it works, what is the voltage of that. Suppose we give in the zero point 0.1 voltage, we will see that there is no current. Okay, there is no current. We will see then give 0.3 volt, 0.4 volt, 0.7 volt. When we will give the 0.7 volt, we'll get a small amount of current. Then we'll give much more, you know much more voltage, 0.8, 0.9, 0.10. We'll see that the current will increase, something like that. So suppose we take 8 to 10 values, manually we give in voltage, we can measure the current using, what is the device of measuring current, my student? Everyone is unmuted in this class. Everyone will be unmuted, because we don't need to mute anyone. Everyone can unmute it. Just mention take measures that there is no noise problem.
Okay, so what's your question?
What is the device of measuring current?
Ammeter.
Ammeter, sir.
Ammeter. And what is the device using to measure voltage?
Voltmeter.
Voltmeter.
Voltmeter. Okay, my student, thank you so much. Can you tell me that how we measure current using ammeter? Is it series connection or parallel connection?
Sir, we connected to the as a in
Series
current.
Yes, while measuring current of a circuit, suppose I draw a circuit.
Okay, draw a circuit.
Yes, suppose I'm drawing a circuit. Suppose this is the resistance. That's it, a small circuit. This is the voltage, DC voltage, and this is the resistance. So if I want to measure the current of this series circuit, how I will place the ammeter in this circuit? Can you explain? Can anyone tell?
Yes, sir.
What?
You can get from the resistor.
Is it series connections or parallel connection?
Serious, sir.
Connected as series connection.
Series connections. Okay. My students, these classes will be always, based on practical. Whatever we understand in the theoretical class, it is quite okay. But we'll discuss much more practically, and we'll discuss. It will be discussion. সমস্যা নাই, যদি তোমার প্রবলেম হয় সমস্যা নাই, তুমি ট্রাই করতে থাকো, এরপর যদি প্রবলেম হয় আমি তো ভিডিও লেকচার আছে, ঠিক আছে, তবু ট্রাই করো একটু। Okay, my student, can you listen me?
Yes, sir.
Okay, so this as we do not have the opportunity to in the practical class, but in this class we'll try to talk much more practically. Okay, practically, and it's not about only me, because in the next class I will give you the topic. At first you will study, you will come up with some knowledge, then we will discuss. This should be the discussion class. Okay, so this is the voltage source, this is the resistance. So if I wanted to measure the current, we all know that ammeter will always be in the series circuit, my students, always be in series, because if you don't if you connect this ammeter in the parallel, it will, ammeter is what? Ammeter is also a load, my student. Ammeter is also a load. Suppose we measure connected ammeter as a parallel. What will be that? Ammeter, there is a small resistance in the ammeter. So ammeter, we all know that when the current will flow, if I connect it parallel, the current will divide, isn't it? The current divider rule, the KCL rule in the node. Do you know?
Yes.
Yes, sir.
Yeah,
Yeah.
the current will divide. So we will not get the exact current. We'll only get from the ammeter current. So for that, let me choose a different color that will help me. So for that, we need to connect ammeter in series. At that time, we will get the current. Okay. Similarly, my student, what is the process? Suppose this is one resistance, this is another resistance. If I want to get the voltage of this resistance R2, what is the process of connecting voltmeter, my student?
So you can connect the voltmeter as a parallel.
Yes, my student, excellent, as a parallel. So we have to connect the voltmeter, the positive terminal here, the negative terminal here. When we'll connect the positive terminal and negative terminal, suppose this is the voltmeter, it should be in the parallel connection. Why? Because we all know that in parallelly, the two branch voltage is same.
Same, yes.
Is it clear?
Yes, sir.
Everybody please give feedback, or otherwise I will lose the motivation.
Yes, sir. Yeah. Yeah.
Yes,
It's good.
yeah, that please try to give them at least react, that yes sir, we are understanding or we are listening. Otherwise I will lose the motivation. Thank you so much. So these things, I believe that from now on, I know that almost all knows, but still from now on, if any teacher asks you that what is the connection of ammeter, what is the connection of voltmeter, is it be mistake? I don't think so. The mistake should not be done by yours. Okay, so the process we are talking about, so the IV characteristics curve in the positive cycle and the negative cycle. And we all know that in a silicon diode, when it is goes to the 0.7 volt, when it crosses the 0.7 volt, that we get the current. We get the current of, okay, huge amount of current. So that is forward bias. And then in the reverse bias, except Zener region. Zener region is different thing. We're not discussing about Zener region. A small amount of current, a pico nano milliampere current flows. So this is the thing we will discuss today. This is the thing we will discuss.
Sir,
Sir, please.
sir, is there any specified value in about in a Zener region?
Sorry. One more time.
Is there any? I say to you, in is there any specific or specified value? For example, in inverted bias condition,
Yes.
you have to reach 0.0 volt potential barrier. So how about
Yes,
in the Zener region? Is there
Okay,
any
okay.
specified value?
Yeah, definitely. It depends on the manufacturing of that Zener diode. As I told you that in our theoretical class, it was 20 volt. Okay.
Yes,
So
sir.
those that diode is basically made or doped in such a way that when it crossed 20 volt, it enters the Zener region. Similarly, it can have 15 volt, it can have 30 volt, it can have 40 volt, but it depends on the amount of doping there. Am I clear?
Yes.
So it is
Yes,
not
sir.
fixed, my students, it is not fixed. It might be 5 volt. After 5 volt, this diode is, becomes enters in the Zener region. So the doping condition is very big. Am I clear? There is,
Yes, sir.
that's why there is no specific value. It is the breakdown in specifically or in generally, it is a breakdown voltage or the Zener voltage, but the value is varies in terms of doping condition. Yeah, very nice question. At least somebody have the idea. But the 0.7 is for silicon, my student. 0.3 for germanium. Okay, but we are
Sir,
talking
is there
about
any specified value about in a German arsenide?
gallium arsenide. There is a specific value. There is definitely a specific value, probably 0.3 to 0.7 in between. But I don't have right now in my mind that what is the exact value. If you search, it will get it. You will get it. It is
Okay,
already
sir.
available. Okay, but I don't right now in my hand. Here I don't have the exact information.
Okay, sir.
So
Thank
yeah, thank you so much. So you see that it gives much more clear drawing, much more clear drawing, that there is a small amount of current tends to increase. When it reaches the Zener drawing, then it goes the breakdown. And in the forward bias conditions, in the 0.7, when it reaches the 0.7, basically it starts flying.
you.
Yeah, this is the so today we in the Proteus software we will try to replicate this and we'll try to see that how is the graph comes such a way. So that is our first task. My students, in our laboratory class we are going to just give that voltage and a different value, something like that, different value. You can see the point, and we are also checking that the point. Okay, so we'll see that when we give the voltage, so we see that when we get the the voltage across that, after that it will be much more we get the more current. So similarly in the reverse bias condition also, we connect the diode across the reverse condition and we give the voltage. We see that a very high, we measure the current by the ammeter. But can you, my students, can you tell me which device now we can use in place of ammeter and voltmeter?
Multimeter, sir.
Multimeter, yes, multimeter. Multimeter can give us, the opportunity to measure both voltage, current, resistance, so many things. Okay,
Yes, sir.
excellent, excellent. Frequency also, my student, frequency also. Okay, it can also measure the frequency, the multimeter. Thank you so much. And those are wondering that, sir, we are studying the theoretical course. No, my students, I'm just first of all describing the whole process. This is the way of conducting a lab. First of all, describing the whole process, then we'll go to the E section, the simulation section. So I have you see that the objective of this is the study of the IB characteristics of diode. The theoretical, you already know that if we connect the diode in the same manner, something like that, the P is the positive and the N is the negative. This is the forward bias, and these are junction diode. Okay, this is the diode practical structure. This is the diode in the PN junction structure. When I told you that in the N side or the cathode side there will be a black strip. Okay, let me give you a much more clear image. In the next, so this is the the conditions of the how this is the positive bias condition connecting with the positive cycle, the positive voltage, and this is the condition of the negative voltage. Okay, same, there is no big thing. Yes, you can give your role in the chat box, everyone. So my student, if I go to the next, this will be the equipments will be required for our for conducting our So you see that the p-n junction diode, the diode we will use, the mostly popular diode, the silicon diode is used 1N4007. This is the you know this is the model number. This is the model number of diode, the p-n junction diode, the most popular silicon diode 1N4007. And we need a resistor. We need a resistor because of because when we apply more voltage, the diode may not withstand that. That's why in practical we need resistor. We need DC power supply, signal generator, where we generate the signal for the signal generator is basically for the AC, but today we'll see the DC. And the trainer board, the oscilloscope, the digital multimeter, cords, and wire. These are some basic equipments for conducting this kind of things. From here you can see, my student, that this is the practical image of a diode. When you see this type of strip, either I told you before, either a white strip or black strip. When you see a strip, you will definitely know that this is the cathode or the n side, and when you see nothing on the other side, it will be anode. So this is the way of identifying a diode. Am I clear? So this is the way. Always see that, because in the diode it will be not written that which is positive, which is negative. But when you see a black strip or white strip, okay, at that terminal will be the cathode, and the other terminal will be the anode. Let me have much more. You see, this is much more clear. Is it clear, my student?
Yes, sir.
Yes, you see that this is the closer image of a diode. You see that this is strip, this is the cathode marking. This is known as the cathode marking, because if there is no marking, you cannot identify which one is the cathode and anode. So you cannot identify that. But when it is a strip marking is given here, so we can now identify that which one is anode and which one is cathode. So we all know that the direction of current flow always from anode to cathode, isn't it? From P to N.
Yes, sir.
Okay, so we studied this in the theoretical class. Always you remember that always the direction of current flow from anode to cathode. Similarly, this example, this picture gives us much more clear idea and helps to enrich our information. So this will be something, the experimental setup or the circuit diagram. In practically, we will use the resistance, because when we increase the amount of DC voltage, this diode is made of a material may not withstand that amount of voltage. It may get damaged. So for that, to why you use resistance? Resistance is the limitation. Resistance limits the current. It always blocks the current. So that's why it has the voltage drop. Are you clear that? What is voltage drop? Voltage drop means when the current is flowing smoothly here. When it goes to resistance, it needs to flow here and there and here, and that's why at that time the voltage drop falls there. So that's why it limits the current resistance. I know that you know this kind of things from the electrical circuit courses, but it's just for the reminding purpose. So this is the whatever I'm discussing is just giving you the if I am taking the class in practically, I will explain the same thing. But after the discussion, the difference will be we will apply in our circuit practically. Now we'll go for the simulation. Okay, so that will be the difference. But the understanding should be clear, crystal clear. Am I clear, my student?
Yes, sir.
Yes. And this will be the data table. This will be the data table. We will go. We will put. You see the different columns, different rows. In this column, probably we will put different value of DC voltage: 0.1, 0.2, 0.3, 0.4, 0.5, and we will check the diode voltage, and we'll check also the resistance voltage. Okay, VR means resistance voltage. And finally, we just divide, because when we select a resistor, we have the resistor in our hand, something like that. If we go there, because VR 1k resistance. Suppose VR is 2 volt or 3 volt. If we divide by VR by 1k, we get the series current, isn't it? Because the current in this circuit is series current. So that's why the current flowing across the resistance and across the diode is equals to Same, isn't it, my student?
Yes, sir.
Yes,
Yes,
sir.
it is the same current because it's a diode series current. So that's why from here we can measure the diode current. So when we measure the diode current, we have the this voltage, we have the voltage, my students. Here we have the current here. So if we go to the use these two table or two column, we can plot easily the graph, isn't it? In the x-axis we plot the input voltage, and in the y-axis we plot the id current. Am I clear?
Yes, sir.
Okay, that's how we basically build finally the IV characteristics graph in our hand, and finally we see that the pattern are looks like the same, exact same. Just we saw that in the first slide of this course. So I think that you already got the process. That what is the process of finding out the value? Is there any confusion, my student? My students, is there any confusion?
Yes, sir. No, no, no.
Where? Where? Tell me.
Oh,
Tell me, my student. Tell me.
I said no, sir.
Okay. No, no. Other students. Okay. So basically, let me check that this forward bias graph and this reverse bias graph in the. Um, can you see my screen?
Yes, sir.
Yes, sir.
Okay. So I have probably yesterday I have tried that. Okay, no problem. I will start from the very beginning also. And I believe that you have already know that the basic of Proteus. Sorry for the slowness because my laptop is very slow. Okay, so okay, let me remove everything and it starts from the very beginning. Can you see my screen?
Yes, sir.
Okay. So basically, my student, in this Proteus, I think that you have already which course you have used in Proteus, my student?
Circuit one, sir.
Circuit one. Okay, nice, nice. Circuit one, yes, it's very useful for analysis of circuit, the current, voltage, something like that. So we all know that this is the component mode. In the second terminal, this is the component mode. So we need to click that, and in the P we get the component. So here in the keyword we always the pick device. Okay, we always search for the component name always. Okay, so first of all, our basic need was the diode 1N4007. Okay, so I in this experiment we only need that diode 4007 or 401, same thing, almost same thing, just in the doping level of the rating level. So I got this, I got my diode. So what I will do, I will just take that click that diode and click in the screen here. Can you see my screen?
Yes,
My
sir.
student, can you see?
Yes, sir.
Okay, I just pick this diode here. I just pick this diode here. After that, what I will need? I will need definitely a DC source, isn't it?
Yes.
Yes, sir.
A DC source. So here the generator mode. You see that a symbol of generator mode. You go to generator mode, you get the DC. Here at the very beginning, you get the DC. So I click here, I get the DC. So I put there. I put this here, and we got our voltage here. We just connect with that diode.
The upper side.
It's connected. What else is needed? We have positive voltage. We need a ground, isn't it? My students, we need a ground, isn't it?
Yes, sir.
Yes, when we go to the terminal mode, you see that here is the terminal mode. We have the ground. Here we click the ground, we place here, and you can see the ground is here. Yes, then we connect the diode with the ground. Let me zoom that so you can have better understanding. I think that now it is clear. My
Yes,
student?
sir.
Yes, sir.
Now it is clear. So what else we will do? We will do, sir, let me, first of all, let me, change the voltage. Okay. You see that if we double click there, the voltage starts from 0. But I wanted to see a continuous voltage. Okay, continuous voltage. That will give me the proper value. So I will make that 0 voltage to X. So that is the variable. So it will vary the voltage from 0 to a certain level. So that will give, that will make our graph understanding. So at first we make that, and what else we needed, we the IV characteristics curve. That means that we need the diode current, isn't it? What is IV characteristics? We give voltage, we need to see the current, that what is the current situation. So for that reason we will go to the probe mode. Probe, just the generator mode less the probe mode. Probe mode, we can see the voltage, current tab. So we will need current. So we just point here the current. So this is the, we just pointed the current. So we just double click there and change the name of ID. ID means the diode current. So now the ID will represent the diode current. So as it is the the what can I say, as it is your current is now the circuit is closed. You can see that the diode here, uh, if I'm making in the zoom, it is diode here. We have the voltage, that is the range. We have voltage, we have connected with the ground. So is it forward bias or reverse bias, my student?
Forward,
This
sir.
is forward bias.
Forward bias. Yes, because of let me give, because it is positive terminal and it is negative terminal. My students, this is the DC line, but think like that this is something like that. Okay, this is something like that. You don't need to worry
And
about that.
here is the negative terminal.
Yes. Am I clear? Yes,
Yes, sir.
yes, this is something like that. It's drawing something like that.
Exactly, sir. I'm so confused.
Okay, probably you everyone know, but still I'm just showing.
Yes.
Okay, so this is forward bias.
Yes,
Now what we'll
sir.
check?
I've never seen this one.
Yes,
Exactly. Yes,
tell.
sir.
Any problem?
No.
Any problem?
No, sir.
No, sir.
Okay, okay, thank you. So what we'll do now, we want to see the what is the current, how the current works. We go to the graph mode here. We in the you see that if we go here, we get the graph mode. And the graph mode, as we are applying the DC voltage, so we are the DC sweep. This is particular dedicated for DC analysis. So just drag it here. You can see that the DC sweep analysis. So from this graph, we can see what is the DC sweep. So we double click that DC sweep, or double click the DC sweep, and finally, we can, sorry, single click and add trace. We go to the add trace, and we need to, which probe we want to see. We want to see the ID. We select ID and select OK. One more time, I'm showing that. Just right click here, go to add trace. Add trace means you need to add the probe. Probe means which which parameter you want to see in the graph. Add trace. Here the probe is given probe 1. So basically we have DI, the voltage, and also the current, but we wanted to see the voltage ID. So ID, we just OK. So it is added. Finally, what we will do, we just simulate the graph. If we simulate the graph, can you see my student?
Yes, sir. Yes, sir.
My student, can you see the graph?
Yes.
Okay, okay, make it much more larger. Make it much more larger so it will understand. Can you see it right now?
Yes. Yes, sir.
Yes, sir.
If you see properly, uh, okay, I need to a little bit less. It becomes too large to portray. Okay, okay. Let me have the, yeah. Okay, if you check properly, I'm using the drawing also. Here, this is the IV characteristics graph. Here, the x-axis is, my student, x-axis is,
I, sir.
what is x-axis?
I.
ID, sir.
No, x-axis is not ID. X-axis is V, input voltage. X-axis, this is x-axis. What is y-axis? The diode current, isn't it?
Yes.
Yes.
Should I need to see one
That
more time?
was related to the graph.
Sorry. Okay, you see that exact
Hello?
this 700. Yes,
Can you
tell.
hear me?
Yes, tell.
Sir?
No, I cannot hear you properly.
Nothing, sir. But can you hear me?
Yes, tell.
No problem. No matter. I have no problem.
Okay. So you see that exact this 700 milli. 700 milli means 700 millivolt means what does it mean? That is 0.7 volt.
0.7, sir.
0.7 volt. And we all know that what is the barrier potential of silicon?
Is
0.7, sir.
0.7 volt. So we can see
Yes.
that from 0.7, when it crosses the 0.7 volt, the current starts to
goes up.
rise. Okay.
Yes, sir.
Is it matching about our theoretical knowledge?
Yes, sir.
Is it matching? Yes,
Yes, sir.
it is matching, sir. If we apply it similarly in the practical life also, we'll get almost same result from this kind of experiment. Am I clear?
Sir.
Yes, sir.
So you try your home also. Those have the opportunity, but those do not have the opportunity. What can I do? I can just tell you that you see my video one more, again and again. That is the facility I have. You see that a point from
Yes, sir.
this is the 0.7 volt. So from 0.7 volt, we can see that the current is rising. So in the similar manner, my student, if I go, this was the forward bias or reverse bias? My student, this is
Forward,
definitely
sir.
the forward bias.
Bias,
Yes,
sir.
this is definitely the forward bias. And let me take a picture, so which will be helpful
This
for.
is forward bias, sir.
Yes, let me take a picture for other students so that they
Forward
can.
bias.
Sorry. Let me take a picture so that for the other students, so that okay, let me take a picture so that will help you. My students, we need to do as much as possible, because we right now we don't have the facility of so that's why we are trying our best to at least see in the simulations. So this is forward bias, my students. So what we'll do, we'll just go for the reverse bias condition and check that how the diode looks. So place the diode one more time. But right now, what we'll do, we will rotate 180 degree. So this is, you see that this is 180 degree. Okay, 180 degree. Now, because we need to connect this in the reverse bias condition. So we'll go to the generator mode again and go for the DC and connect the DC supply and connect with. Now you see that, is it forward bias or reverse bias?
Reverse bias.
Reverse, sir.
Reverse bias, definitely, because you see that now the cathode is connected with positive voltage. Okay.
Sir.
Yes, tell who?
Yes, sir. The N region is connected to positive, sir.
Idris.
Yes, that's right. It's reverse bias.
Yes.
That's why it is a reverse bias. Okay, let me so we want to see the the current of this diode. So we go to the probe mode, we select the current probe and then place here. Okay, so place here. We also need to change the name, so that will identify ID2. Just write the
Yes.
ID2. Okay. You will see that it will be changed. Not changed. Yeah, it's changed. ID2. So ID2, now we want to see this graph into the graph. So go to the graph mode, go to the DC sweep, and finally make a one more graph. Finally, place one more graph. You can see now we go to the right click, go to the add trace. We will add that which probe we wanted to see. So we will add the ID2 because we wanted to see the ID2. Now it is finished. Now we go to the simulate graph, and when you simulate the graph, can you see, my student?
Yes, sir.
What can you see?
Nothing, sir.
Almost, yeah, it is almost zero current, isn't it?
Yes, sir.
Practically, it is zero current. You see that? A small current, not exact zero, very small current, it is flowing. So that means that in the reverse bias condition,
0.2.
yes. Okay, let me take this picture first, because for all of you, almost zero current flowing, very negative, which is very negligible, my student, very negligible. So this is the reverse bias condition. In the reverse bias condition, the diode, hardly flows any current. But in the Zener diode condition, this is different, my student. This is different because when it crosses the Zener voltage, it totally becomes something else. Okay, so at that time it becomes the voltage. We will also see. We will also see in our simulation also. So that was the thing that I wanted to figure it out, that in both the diagram and also in the simulation side. I have already given the software link, my student. It's very easy to just download that and go to the exe file, just install, nothing else, and run by administrator. And I believe that some of the students have already the software. That is
Sir,
excellent. Yes.
sir, and on the software, there's a problem that says no library found.
Yes. That's why I told that you have to run as administrator. When you open, don't just double click, something like that. Let me show you, my student, one more time. I have faced also the same problem. You see that my software here, Proteus. You go to the right click. Can you see?
Yes, sir.
Hey, that's the run as administrator. Can you see this?
Oh,
You always
yes,
run
sir.
this using this run as administrator.
Yes, sir.
At that time, it will not create problem. Also, I have faced this problem also. I have also faced this problem because these are the cracked software. You all know that it is a cracked software. The problem can happen anytime. So, is it clear, my student, the IV characteristics curve?
Yes, sir.
Yes, sir.
I also believe so, because I tried my best that whatever I can from the distant learning. But still, if you face any problem, definitely Google it. I have a video. Amir, can you hear me?
Yes, sir.
Is it will it create a problem if you add me your Facebook group? So at that time I can post from myself much more videos, and it will be
Okay,
helpful
sir.
for me, because I can post directly, so I don't need to dependent on you or some other students, because I can post my PDF, everything. So you know that if it is not if it not create any problem for any privacy problem, if it is a if you say that, sir, no problem, sir, I will post on behalf of you, it is okay, then it's okay, my student, then it's absolutely okay. Okay, so my student, I tried my best. So this is also a recorded video lecture will be provided. Software has already been given, and the PDF will be also been given. So is there any problem, my student? Any questions? I don't think so. And almost all the students are present, just like
No, sir. I should.
sorry, 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 I cannot understand. Is there any question?
No question, sir.
No, sir.
This
Okay,
is clear.
okay, okay, my student, that's it for today. I think that you have given your role in the chat box. Let me see that chat box one more time. Let me see the chat box. I think that almost same students have been present here. That's excellent. I will tell Hasnat and the Bengali students that please tell your Bengali friends to join the classes, because you know, it's very important, because we have only 1 month left for our final exam. So all the classes will be very important from now on. So please tell your friends to join the classes. And that's it for today. That's it for today, my student. And hopefully that you understand my whatever I'm trying to say. I will deliver everything, the video lecture and the PDF after they finish the class. So that's it. Can I end here, my student?
Thank you,
Yes,
sir.
sir.